Hi all, welcome to the Polycraft Physics video series. In this series, we will be covering the 5 most common college mechanics topics. There will be several components to this, including an interactive game component in Polycraft, a Minecraft mod. Be sure to download it and play each level corresponding to each video. In this video, we will be going over kinematics. What is kinematics? Kinematics has 4 components: position, velocity, acceleration, and time. Velocity is defined as the rate of change of position. Here is a car standing still with 0 velocity. Its position is constant. Here you can see a car moving horizontal at a constant speed. This is a change in position. The faster the car, the faster the change in position. Acceleration is defined as the rate of change of velocity. Here is the same car speeding up. This speed is no longer constant. Its acceleration is now constant. The faster the car speeds up, the faster the change in velocity. For the purposes of this course, we will only be dealing with constant acceleration. To solve a kinematics problem, you need to know a few important equations. Let's go to the drawing board. This is the constant velocity equation. Delta d is equal to vt, where delta d is change in position, v is velocity, and t is time. This reads out as the change in position equals the velocity multiplied by time. Only use this equation when there is no acceleration, or in other words, the velocity is constant. As a quick side note, a change in position means final position minus the initial position. The same thing applies when someone says change in velocity. When there is acceleration, you have several options. 1. Vf is equal to Vi plus At, where Vf is final velocity, Vi is initial velocity, A is acceleration, and T is time. 2. Delta d is equal to 1/2 At squared plus Vit, where delta d is change in position, A is acceleration, Vi is initial velocity, and T is time. 3. Vf squared is equal to Vi squared plus 2a delta d, where Vf is final velocity, Vi is initial velocity, A is acceleration, and delta d is change in position. Great! Now we've got the important equations. Let's solve some problems. Another common kinematics problem that you will see has to do with throwing a ball. Here's an example. This problem is meant to teach you how to split a kinematics problem into 2 components, horizontal kinematics and the vertical kinematics. Let's start with the horizontal component. The horizontal component of velocity, or Vx, is constant. It has no acceleration. This is because, as you will see in the next video, only the vertical component has acceleration as gravity is acting on the ball. If this doesn't make sense right now, that's okay. It will make more sense once we cover Newton's law in video 2. So, Vx is constant. That means we can use this equation for constant velocity. Delta d is equal to Vt. We know the change in position on the x-axis. The ball moves 20 meters from the roof to point B. So, 20 is equal to Vxt. To solve for Vx, we need to see how to connect it to Vi. To start, we can split the velocity in 2, like so. Using the basic trigonometry of a 45-45-90 right triangle, we know that the cosine of 45 degrees is equal to Vx over Vi, and cosine of 45 degrees is also equal to 1 over square root of 2. So, Vx is equal to Vi times the cosine of 45 degrees. Vx is equal to Vi over square root of 2. Backing up to our original equation, 20 is equal to Vx times t. We now know that 20 is equal to Vi times t over the square root of 2. Solving for t, 20 times the square root of 2 over Vi is equal to t. That is the end of the horizontal component. However, we still don't know Vi and t. Where can we get that information? By looking at the vertical component of the problem. A helpful math hint is that to solve for 2 unknown variables, you need 2 equations that both contain those 2 variables. In this case, our two unknown variables are vi and t. And we already have one equation. 20 times square root of 2 over vi is equal to t. To get a second, we need to remember that we have three kinematics acceleration equations to choose from. Equations 1 and 3 both have vf in them, which is an extra variable that we don't want to deal with. Equation 2, on the other hand, includes only known variables. When solving for the vertical component, we will denote everything in terms of the y-axis by adding a y subscript to each variable. Delta dy is equal to 1/2 at squared plus viy(t). In this case, delta d is the change in position on the y-axis, which is just the height of the roof. The change in position doesn't take into account anything that happens in between the initial position and the final position of the object. All that it includes is the final position minus the initial position. In this case, the ball fell 10 meters, so delta d is equal to -10. Additionally, a is equal to the acceleration of gravity, which we will call g. On Earth, the accepted value for gravity is near 9.8 meters per second squared, which is what we will use here. Gravity is pointing down in this case, so g is going to be equal to -9.8. Finding viy works in the same way as finding vx, using the same procedure of splitting the components using trigonometry. viy is equal to vi over the square root of 2. Plugging all of this into equation 2, delta d is equal to 1/2 gt squared plus viy(t). Now plugging in the numbers, multiplying the square out and canceling the vi and square root of 2 in the second term on the right side of the equation gets us, solving this down, we get vi is approximately equal to 11.43 meters per second. Now that we have vi, we can easily find t by using the equation we found while solving the horizontal component. 20 times square root of 2 over vi is equal to t. Now we have t is equal to 2.474 seconds. Now that we solved these problems, you're ready to try your hand in Polycraft. Open up Polycraft now and play Name of Game. Thank you for watching the Polycraft Physics video series, Video 1. We'll see you in the next video where we cover Newton's laws. Peace.
Yeah.